Hello. Today we're gonna build the thing that was missing for a working example last time. So last time the problem or what I did was uh, adapt the text box to the new widget interface and make that make that work. But for it to work as an example, uh, we actually need state, and it's not actually part the of its own state. Uh, as you can see, the interface, the state is text box, which is just its size. So the actual content and stuff like cursor position is a parameter. So yeah, so it's basically some sort of externally managed state, and which is because we want to be able to access and call functions on this to manually or with code edit the text or change it or I don't know, get the cursor position or whatever, which is something that's I think a bit unnatural in many of these types of frameworks, especially on the web. I think in Flutter there's actually these text editing controllers, which are basically that externally managed state. Yeah. So, but it means we need some sort of so either we could just build a wrapper widget around it, which actually has this parameter thing as state, or um, which we then have to manually wrap all of those methods on widgets, like build, update, min size, extra layers, render, and so on. Um, but since that's a very common thing to have basically a build function and an uh, associated state. Uh, I want to build an abstraction there. So basically it's a bit like stateful widget in Flutter. So the statefulness here doesn't refer to whether in total the widget has state, because each widget basically has state, unless you have uh, empty tuple here, but that only makes sense where the size is fixed, I think. Otherwise, you'd have to recalculate the size on each method or something. Uh, so yeah, statefulness here just refers to whether there's additional manually managed state, I guess. Yeah, which is the same as it is in Flutter, because you can have a stateless widget which uses a stateful widget. All right. So I've today I've attempted to build such a thing. Mm, Basically, I thought about there could be a function, and you'd call it with the closure to build the initial state, and then a build function which produces a widget. But I've run into an issue which makes this approach essentially not work. So as you can see here, there's a bunch of lifetime issues, which is only because they're only here because I've tried to move them around, or I've moved them around from somewhere else. So as you can see here, there's the A lifetime and W has the A lifetime, and we return W from the build function. Because basically in the example here, I want to have initial state is just text box content new, and here I want to build a text box from it. But obviously the returned text box can't outlive this reference or this text box content. And expressing that turns out to be, I guess, hard. So um, so yeah, if we just do the simple thing without any explicit lifetimes, we can leave this whatever. Without that and without that. Did that already? No, it doesn't understand. So we'd have to remove it here as well. Right, so as you can see, this compiles now, but this doesn't. Because, yeah, it doesn't know what this lifetime should be. Which makes sense. But, so the issue here is we want to say something like this. For a lifetime A, there's this, and it, I don't know. We really, because this wouldn't be valid in a function either, because W is a concrete type. So what we'd really want to say here is basically impl widget plus A. But since closures can't have any generics, which also applies to lifetimes, it's not really possible to express this. So there is this for thing. But the problem here is I don't actually fully know. Yeah, no, I'm not. That's not a loop. What? Oh, okay. Higher ranked trait bounce. Doesn't actually quite do what we want, and even if it did, like, how would we, with this W here, how would we get this thing to have A? So, yeah, it just doesn't work because what even is A here? A is only defined for this scope. So, and just messing around a bit is what I, maybe I can just revert all this to what I had before. Right, so, but this obviously means A is not per invocation of this, or yeah. So it would have to be statically assigned to the type, which it can't. Because we basically just want to say you can call this function with any A, but that's not possible with closures, or at least as far as I can tell, it doesn't seem to be. So yeah, so that means this approach doesn't work. Unless, of course, we just remove the bound but then we can't have references here. So we'd have to, I don't know, copy it, but that would lead uh, to one of those one-way data flow restrictions, which are sure are sometimes useful, but uh, isn't actually quite what we want, because especially in Rust, I think having mutable parameters will be really useful, and it'll avoid having to have one of those additional state management libraries you have to add on top and so on. So yeah, because my vision is to just have manage application state as like some nested structs and enums and so on, and yeah, just pass mutable references to sub parts of that to a widget or something. So yeah, for that we need references with non-static lifetimes, uh, unless we put them behind reference counted things or something, but that's not quite, yeah, it's not so, it requires additional memory although not necessarily a lot, but yeah, it has some overhead, and yeah. So what I want to do now is essentially build a trait for stateful widget, so which basically contains the init state and build functions. And then there's two possibilities. So here what we did, so this by the way is just a marker I've tried. I'm usually not one for having phantom data all over the place, but the problem is if you don't have this here, remove it here, then it says W is not used. But it only says that if, or is not constrained by impl trait, self-type, or predicates. So unconstrained type parameter. Interestingly, this goes away if you remove the reference here, which is odd. But yeah, so that's why I tried the phantom data thing. Yeah, but so yeah, this approach doesn't quite work, so we'll implement a trait. So it would be, or yeah, by the way, so this just contained the init state and build function, but that means you have to call build, like here we call build, here we call build. No, that's the wrong build, this one. In each method you have to call build, except for those, because I added those explicitly to the state. But of course, instead of this phantom data, we could just actually also store the widget as an option or something. But yeah, so I think I'll do that to avoid the whole overhead of building again and again. which wouldn't be that much of a problem because build shouldn't do stuff like allocate memory, but it's still unnecessary overhead. So, but that kind of gets relevant because if I have this trait, let's just call this stateful widget. What I could, of course, do. So if we just have methods for init, state, and build in here, what I could do is just have a blanket impl for w, which is stateful widget, impl widget for w. So, which means we can just implement this trait and we have ourselves a widget. But that means I can't have additional fields, which I will or might want to. So I think instead of doing a blanket impl, I'll just have a wrapper struct. Yeah. So right. No constraints. So we'll have this is pop. We'll have init state, which takes does take anything? Wait, I think it doesn't. Self state, which be type state, yeah, whatever it is. Then build, which or I guess instead of doing this with an associated type, we could just do this. It just returns self, and here it takes self and produces widgets. Ooh, yep, now that's a problem. Yup. Type widget. But what we really want is impl widget. But for that, we'd need generic associated types. Fuck. So I don't know what the solution here is. Because if we go back to this, type-wise this would work, but the problem is that this type has to be nameable, and quite a lot of widgets won't be nameable. Shit. Okay, I cannot think of a clean solution right now. So wait, if I have a struct a whatever, and I just impl, can I use infiltrate there? Init state or no, call it build. Impl widget. Probably not. Ah, no, I need a body. Right. Okay. It's stopping because of other errors. Let's just comment that all out. And right. Trade bound, not satisfied. Okay. So it seems it's not forbidden here. Yeah, makes sense. Because this doesn't really need generic associated types, I think. Yeah. So, yeah. I guess we could do something with that and the macro, which assumes there's a function named build or something. But I don't. I really don't like that. Yep, that'll be a problem. Okay, I don't think I can come up with the solution for that on the spot. So, yep, no progress has been made. I think I'll stop here and maybe find a solution. But yeah, it's a bit unfortunate. I really don't want to have to wait for generic associated types or or generic closures for that matter. But I think generic associated types will probably be a thing before generic closures are, but I don't want to have to wait for either. So, yeah. That's, yeah. I'll have to think of something. All right. See ya.